For Azure automated deployments, Microsoft actually provides some PowerShell tooling. So they actually have a whole PowerShell ecosystem for Azure deployment and automation. So if you're using Azure, PowerShell is a great tool to get to know. And the great advantage of that also is if you can run PowerShell scripts both locally and from a CI server, like Azure DevOps or something. So you can create, test, and perform all those automation functions locally first, and then simply get them working in a pipeline, as opposed to having to build stuff in the pipeline manually. So from that perspective, PowerShell is a really great tool.
The digital tides are turning in South Africa. Here, the code dictates the very fabric of the days to come, written line by line. Join me as we unveil the stories and decode secrets shaping this digital revolution. Discover hidden careers and unlock your inner tech potential. I'm your host, the Black Cicada. This is Binary Talk, your gateway to the future of tech, right here in Mzansi. Well, you can start by saying your name and what you do.
My name is Nic Louw, and I'm a software developer and an integration architect.
Tell us a bit more about your background, how you got started in the field.
Actually thinking about this the other day. I initially was involved with process analysis, trying to figure out how to run a specific non-IT department more efficiently. And then I ended up chasing the more interesting problems into computer software. I had a bit of background. I mean, I'd done it at school. I'd done binary mathematics and so on. But I honestly never thought I'd do it for a living. But yeah, in 1997, I started working on a team of 3 people, doing some Windows desktop dev. And then it kind of grew from there. Got involved in writing some ERP systems, moved onto the web when it became a thing. And today it's all the cloud. So at the moment, doing a bit of cloud development.
Could you explain about cloud development? Is it any different with software dev?
That's an interesting question. If you start digging into, I think when every developer starts, we start looking at frameworks. Everybody's search Stack Overflow and try to find a code snippet and just paste it in and hope for the best. But as time goes by, you begin to realize that all these different frameworks solve essentially the same problems. And in my software development journey, I stopped looking at frameworks eventually and started looking for patterns, because you find over time all the frameworks keep changing, you keep getting new ones, and you get tired of learning how they do X or Y in a specific framework. So you learn the broader patterns and how that's put together. Now with the cloud, it actually provides you a lot of those patterns out of the box. So while it's essentially the same problems being solved in a similar way, it's on a broader canvas. So the tools are a lot simpler, but they're designed to solve the same problems in a different way. So instead of component communication, we have a service bus or Fabric API, things like that.
What's the most significant change you've seen in the industry?
One of the first ones was the change to Microsoft.NET on the Microsoft side. Java had always been the cool kid. Microsoft was stuck using things like COM+ or C. It's manual memory management. None of the we were so focused on just getting the thing working that you didn't really have time to build a rich user experience. And so there was something called Visual Basic 4, 5, and 6, which gave you easy tools to get stuff up and running, but it came with its own issues. And finally, when .NET came out in about 2001, 2002, it was finally Microsoft's answer to the Java ecosystem to make things a bit easier. Before that, there were things, you speak to any old developers and ask them about COM and COM+, they'll probably start rolling their eyes or tearing their hair out. But the whole arrival of contract-based SOAP and REST APIs, a way to communicate between different systems without having to do low-level programming and try and get stuff to work over the network was actually a phenomenal change. Sort of the rise of properly networked stuff, the internet. One of the interesting things about that was these days I know people complain about SOAP and how heavy and complicated it is. But at the time, it was a revolutionary solution to a persistent problem, getting different systems talking to each other. So for me, that was the one of the biggest changes I saw. And the rise of the web too, and JavaScript applications, as opposed to heavy desktop or two-tier apps, was quite a phenomenal change for me.
You were referring to SOAP as in SOAP API. What could actually be the difference between a REST API and a SOAP API?
Well, REST is the cool kid. So when the REST paradigm came out, it came out as a response to SOAP. So SOAP came out as a response to the distributed COM or DCOM or COM plus, which was a way to make remote procedure calls on code using essentially binary calls across the network. SOAP was an easy way to say, look, we don't care about this is a protocol, this is a way that we can enable calling between different systems. But the problem with SOAP was those XML packages are huge. And for large data packets, you'd find SOAP running out of memory even for huge messages as they went across the wire. And also it was slow. All of the validation and the parsing of the XML was slow. It was ugly to look at. There was a lot of duplication. So the idea with the REST was to actually go back to the whole HTTP idea, the HTTP protocol, and say, look, let's get rid of all this extra baggage and just talk about resources. Instead of messages, we're saying, I want to access this resource. I want to mutate this resource. It was a nice, clean way of basically using what the internet had proven worked for messaging between applications. But the problem was initially there was no easy way to define contracts for JSON web services. And everyone seemed to have a different idea about what REST involves. And so these days, it's become more of a common thing. REST, or at least JSON-based web services, have become sort of ubiquitous. Everyone's using them to communicate between systems. Because it was easier to compress, it was much leaner, not a lot of extra junk in it. And I think that was the biggest change, was to try and get systems communicating in a common way. And of course, now we have this open API or Swagger definition, which makes it so much easier to define contracts between systems. And that was finally what got me on the REST JSON bandwagon, was the ability to contract the communication between different applications.
Right. You speaking of Swagger, I think it's a C# dev tool of some sort. Then you also mentioned Java, but in your explanations you refer mostly to C#. Is it that you use C# preferably over Java, or you've never used Java before?
I used a bit of Java, but, well, not to say I'm not a fan, but there used to be some sarcastic comments about Java implementations where it was write once, debug everywhere. So every Java engine would have its own little peculiarities. But it was way better than what Microsoft had to offer at the time. But I must admit, I'm a bit of a C# fanboy. It was the kind of Microsoft's answer to Java was this whole C# thing, which would allow the whole .NET common language runtime, all of that, where they said language doesn't really matter. We can support any language you like. So there was actually a Java version of .NET at one point. There's still Visual Basic .NET. It all compiles to the same pseudocode underneath. It all runs the same way. But C# was the new kid on the block. It provided native access to all the .NET toys, and it was made to showcase the ability of this new .NET framework that Microsoft brought out. And so I've tried Visual Basic .NET, I've tried the different Java tools, but the power of the .NET framework versus Java for me is all about the metadata. You can find out all about the processes that are running. It's far more discoverable at runtime than the Java compiled Java stuff was for me personally. So yeah, C Sharp is something I like. I'm not averse to Java. There's a lot of the web, a lot of businesses run on Java. And let's be honest, C Sharp stole a lot of the good stuff from Java. But in a lot of ways, having a new framework, a new language allowed them to solve some of the problems that Java had brought along, some of the legacy stuff that caused problems for Java developers.
All right. I could relate because when I came in, I was a Java fan, but now I've seen the cool stuff in C#.net and I don't want to go back.
I'll give you one example of a Java issue that C Sharp solved. Java allows assignments of variables in an iterator. So in a for loop, while you're actually checking the value, you could also do an assignment at the same time, for example, or a loop. And it was very easy to make the mistake of changing the variables of values while you're trying to iterate them in the wrong way. Probably not explaining it very well. But the way that the Java guys would have to work around it was they'd have to put a constant before the variable so they didn't accidentally make an assignment instead of doing a comparison in a loop or in an if statement. Now, the way that C Sharp solved the problem was they simply made assignments in that context illegal. So the compiler wouldn't let you do it. Now, because of legacy Java code, Java couldn't change to just implement that because it would break a whole bunch of code all over the world. And so, in a lot of ways, C Sharp gave us a fresh start, and that's why in a lot of ways it's a lot easier to use, a bit of a pleasure to use.
Can you tell me about some of the biggest technical challenges you've faced early in your career and how they shaped your approach to development?
There was one interesting problem I had fairly early on, which sort of shaped my thinking about IDEs and development environments in particular. We had to upgrade an application from one version of the Visual Basic framework to the next. And there was no easy way in the IDE to do it. It effectively meant opening hundreds of forms, going to each control, and replacing it with the next version of the control. But of course, after about half an hour of doing this, and with a month left of work to go, I decided that there has to be an easier way. And doing a bit of digging around, I discovered that the difference between the two things, while it made a significant difference to the user, the code itself, if you compared the two code files that you changed, it was simply a version number change. And so was able to go via the back door, write a little script utility to loop through all the files and simply update the version numbers instead of having to make manual changes. And we managed to turn a month's worth of work into a couple of hours. And that helped me to realize that there's always another way. Just because that's the way it's done, or even if the vendor tells you this is the way that you need to use the software, doesn't necessarily mean that that's the only way. Of course, a few other experiences also taught me that there's a time to break the rules and a time not to break the rules. So sometimes taking a shortcut is great, and sometimes the shortcut bites you later. So some of the development experience that you gain is figuring out when it's safe to break the rules and when you should just stick to it. Yeah, there's a few other little things. So sometimes there is no solution to a problem. And then I discovered if you change the problem, then you can find a solution. For example, we were doing a lot of text parsing in one solution early on. It's quite a complicated thing to explain, but we were essentially integrating a system which allowed you to highlight equivalent text in different languages in a viewer. So on the one side, you'd have English text, and on the other side, translated text. And you would highlight the phrases in your translated text that correlated with the English. But because of the way the text was being stored, it was actually impossible for us to store highlighted text in our translated value. So the feature was impossible until we kind of changed the problem. So instead of having persistent highlights, we figured out a way to actually draw the highlights each time we loaded the text field dynamically. And so even though the way we were storing the information wasn't strictly speaking correct, it provided a good enough solution to solve the problem. And that was quite an interesting learning experience for me as well, to see how You can write software that's good enough, just good enough. It doesn't have to be perfect. Just getting it out there is the most important thing, especially when you have an urgent business problem to solve. One important lesson a senior developer taught me earlier on was the best code is code that you didn't have to write. Using other people's code, especially somebody like Google or Microsoft who spent billions to write their code and test it. If you can use their code rather than have to do it yourself, you're a winner. You're getting the best possible code available without doing any work at all.
Yeah. It's a repeated code out there somewhere.
I learned a valuable lesson about repeated code as well. Is sometimes it means you've got to change the way your program works so that you're always calling the same code from different places. But sometimes it's just not worth the effort. And copying it a few times is the lesser of two evils.
Well, in your experience, how have best practices for integrating legacy systems with modern technologies evolved over the years?
Interesting. There's actually a great book about that. I can remember the author, but it's called Working with Legacy Code. And it's a bunch of practices that came up around the late 90s, early 2000s about how to safely transform legacy code into something that works in a new framework or system. One thing that I've discovered is if there's unit tests, it can make it so much easier. It's the easy way to guarantee that the stuff that used to work still works. But of course, in just about every legacy system I've had to migrate, there have been zero tests. So the question is, how do you solve that problem? One way around it is to actually slowly build a test base in the old framework, the old version, so that you know how it works. And then migrate those tests first so that in the new code base, you guarantee to get the same behavior. So those principles are timeless and universal. There are tools to do stuff, to move from one thing to another. But inevitably, those automated tools always made a hash of things. I'm very interested to see how AI or large language model learning can help with that kind of problem, to translate things into from one language to another in a consistent and effective way. Because I must say, the old migration tools provided by different vendors have never really managed to solve the problem very well.
You did touch that you don't have any much experience in AWS, but it's been referred to more often, maybe moving some stuff from AWS to Azure and all those. What is your experience with both Azure and AWS? What are the pros and cons that you may give?
I must say, with AWS, where I've used it in the past, has just been a place to put virtual machines. That's a VM that you would run locally or on your own hardware, stick it in the cloud in AWS. But the problem with that is that that's probably the most expensive way to use the cloud. In one project I worked on for AWS, really gave ourselves high fives because we managed to consolidate code to run 8 instances of particular application on one AWS virtual machine instead of 8. And we basically justified a paycheck in a single month by consolidating all that because of the massive expense of running it. But these days, it's all about compute, though. So this is why doing a lot of corporates, for example, were sweet talked by vendors into saying, you can move your whole business into the cloud. And they would simply stick a virtual machine in their cloud infrastructure and say, there we are, we're cloud native. But specifically with AWS, I think they started to let people know that it's all about compute, Microsoft as well, to rather use shared infrastructure in a way that you only pay for it when you're using it. And I think that's where the real value of cloud adoption came in for me. The problem with doing it the other way is that you're buying all this infrastructure and you're using it for a fraction of the time. In that regard, I must admit, Microsoft has always been great at this, is they woo the developers with easy-to-use tooling. And then the developers seem to push everybody else to, hey, let's use the Azure platform instead so that we can take advantage of all of this great stuff. So for me, I'm a bit of a Microsoft fanboy, unfortunately, because of the easy tooling that they provided. the ability to write logic apps for compute in a way that doesn't consume resources unless they run, and the simple user interface and mechanisms they put together made it very easy to adopt that framework when migrating business solutions from like an on-premises thing to a cloud-native infrastructure. AWS, I know they have their own thing. They have something similar, Lambdas and so on, that they've brought in. And I haven't explored it very much, to be fair, but it is a bit more of a learning curve, I think, to make proper use of all of that stuff. There is a way around it, of course. So, I mean, we can always do things like Docker images, and that sort of thing. And that's kind of for Azure functions and that sort of thing. That's the same kind of thing, where you're running a microservice that sort of halfway between compute and a virtual machine, trying to give you the best of both worlds. But it's still a little bit more expensive to run things that way. So for me, Azure makes it easy to access the cheapest parts of the cloud. And while AWS might perform better, it's been a bit more of a learning curve, and that's why I think I haven't quite gone that way yet. Sounds like an excuse, doesn't it?
You have got vast information. Most of the time, every update that happens or if there is a change, we hear from you because you send links. This is what is new and all of those. How do you actually keep track? How do you manage to keep track of all of this information and changes happening out there?
I must say, Microsoft, for all of their flaws, they're great at communicating with developers. Often their portal will provide some suggestions or some alerts. I subscribe to a couple of Microsoft newsletters, and I try and read about changes coming up. These days, you can add it to your news feed, and that'll give you the keywords for Azure or cloud. Get quite a bit of information that way. But a lot of it comes from Microsoft, and that's always been true. Even back before the internet was a big deal, they used to have what was called the Microsoft Developer Network, where they would actually send out CDs at the time with a compiled module of all of the API and help documentation for the entire suite of products. And you could actually search there for problems and solutions and get in-depth information about stuff. And they would release this every couple of months. You'd get a new version of it. You could install it on your machine for local browsing. And that's pretty much what makes working with their stuff a bit easier, is the abundant documentation. And if you find their documentation a bit painful, because there's so many developers using their stuff, there's a real abundant supply of additional blogs and third-party information available. So I try and keep up to date with a couple of those, things like Stack Overflow, Medium, so on. That gives me a bit of a heads up when things are about to go pear-shaped with Microsoft.
I've always heard about Azure templates. I'm not quite sure what those are. Can you try and explain what they refer to as template?
Do you mean Azure Resource Manager templates? ARM templates, they call them. Yeah. It's great. It's pretty much the mechanism or the language that Microsoft uses to create resources in Azure. So it's for the same format and the same information for those templates. You could use them to do anything from create virtual machines, virtual networks, specific logic apps, service bus, namespaces or service buses itself. Any kind of resource you can imagine, you can create using these Azure Resource Manager templates. In fact, when you edit things in the Azure portal, like a logic app, for example, and you save it, what they're actually saving is they're publishing a template that you've loaded, edited, and then redeployed to the framework. So for us, we use PowerShell and the Azure API to actually extract templates, all these templates that we have deployed in that environment. And then we store them in an offline, what do you call it, a source code control system. Now, the advantage of doing that is that we can recover in event of a disaster. But you can also deploy these. There's quite a lot of power in the templates that we don't get to see very often. So you can actually almost have meta templates that help to produce these templates and configure them for you. You can provide variables in a certain interface to allow you to configure them based on different requirements. And we've used that quite extensively too. But the new kid on the block is called Bicep, though, which is a bit weird. And that's using a YAML format, which is a much simplified text format as opposed to the JSON format that's native to ARM templates. And what Bicep does is it actually uses a YAML format to produce the JSON format, which is then consumed by the framework. At the moment, we're still stuck on the JSON format because that's what's native to the framework. So it's a lot easier to make changes and to load the changed values from the Azure portal because it's all JSON. But Bicep is great if you're doing the code first stuff. So you start off with Bicep, but you can generate the JSON files that you need. But until it's native to the Azure portal, we haven't gone that way because we like to use what's there. We don't want to try and get too far ahead of ourselves and get into trouble.
So essentially, the templates are used to limit the manual work and save time.
You can automate everything. Yeah. Yeah. 100%. Yeah.
Talking about automation, what are some of the creative ways you've used PowerShell for automation or scripting in your past project?
Well, look, I never paid PowerShell much attention. I would use things like Ant or in .NET Nant for automation of builds, processes, testing, even code generation, things like that. But I kind of had an epiphany about PowerShell a short while ago. PowerShell gives you access to anything that Microsoft.NET does too. You can use all of the net goodness in the PowerShell script. And so instead of sitting and building a solution, writing even a console application or something basic, you can just throw together a PowerShell script and automate with one run command, automate a whole bunch of stuff that you might need to do manually. So PowerShell for me is a great stopgap measure to be able to automate your common tasks without having to go overboard and build a whole bunch of extra infrastructure that you don't need. But it has been a recent acquisition of mine the last few years.
So do you think it is highly recommended that you understand PowerShell in order to deploy changes? You should be able to at least understand the one scripting language that you can use for automation.
For Azure automated deployments, Microsoft actually provides some PowerShell tooling. So they actually have a whole PowerShell ecosystem for Azure deployment and automation. So if you're using Azure, PowerShell is a great tool to get to know. And the great advantage of that also is if you can run PowerShell scripts both locally and from a CI server, like Azure DevOps or something. So you can create, test, and perform all those automation functions locally first, and then simply get them working in a pipeline, as opposed to having to build stuff in the pipeline manually. So from that perspective, PowerShell is a really great tool. So it's a great way to automate stuff if you can get started with it. It's a really convenient tool to use.
I should go back to my tutorials. All right. More on the software architecture. When designing a complex software architecture, what are some key principles you keep in mind for scaling and maintainability?
These days, a lot of it's all about security, doing stuff securely. But really, I think one of the key things to consider with an architecture is you don't want to over-architect stuff. There's this principle in development of premature optimization. Imagine how it's complicated and how much it's going to scale. And you build this huge infrastructure that might not even be necessary. So not to go overboard with big design upfront architecture, but to try and make it or design it in such a way that it's decoupled enough so you can move the different pieces around and scale them if needed without having to do it up front. And that can be quite complicated, but it's the same principle for component design and development. Same principles apply to broader architecture. Things like considering latency and throughput and that kind of stuff. And then the common stuff to consider. The assumptions we all make when we start writing code, resources are infinite and latency is zero, all of that stuff. Trying not to fall into those traps, but to consider the fact that this is a real world application likely to be distributed. So we need to consider the impact of those various things.
So just to build something that you can make changes as you scale instead of just making it more complex.
That's hard, There's a great quote from, I'm trying to remember his name now, one of the software architecture gurus, who was trying to come up with a definition of what architecture actually is. And everybody he spoke to had a different answer. But the answer he liked the most, which I think is a great one, is architecture is about the important stuff, whatever that is. So some people seem to say it's about the stuff that's hard to change later, which is also a fair definition, or it's the stuff that's important. But really, that's what it's all about, trying to decide on what's important for your application, especially the stuff that's going to be difficult to change later. And the sad reality is you don't always get it right. So sometimes you have to change it anyway. But every time you do it, you learn something else. You learn something new about how systems work and how to scale them. One great principle that I've found is if you can lean on people with the experience, it's a great way to learn without making the mistake yourself. So often a bit of humility goes a long way in getting a solution that works.
How do you see the role of DevOps engineer evolving as these technologies continue to advance?
DevOps, that's quite a thing. Years ago, it's interesting, when I started doing development, the way we would do releases is do exhaustive testing, burn a CD and courier it to the different sites where they would install it manually on each device they needed to run it on. The joke of that was if you made a mistake, it would be 3 months before they would get the fix. And trust me, I made some pretty interesting mistakes. I'm just glad they never ran the code that I'd written before we picked up what the problem was. And with this whole continuous integration, continuous delivery, that's really changed. You can make a bit of a mess and then in an hour it's fixed. And hopefully nobody even noticed what kind of mistakes you made. But as it carries on, though, in a lot of ways, that's kind of what people expect now from a development experience, that you can push an update the same day or even in an hour or two, a hotfix. So definitely there's a role for people who know how to make that happen, to design systems and processes to enable that in a safe way. Things like testing and an architecture that embraces change as opposed to shying away from it, as well as getting to know the automation tools, Azure DevOps pipeline and proactive application monitoring so you can pick up issues before they happen. I think that's definitely improved the user experience, and that's kind of where we are now. I'm curious to see how AI-driven tools might even make it easier for us, sort of accelerate that or give us more tools for doing the heavy lifting to figure out how to configure pipelines in a way that makes it easy for us as developers and also safe for the consumers of whatever the pipeline spits out on the other side.
Interesting. What's your approach to debugging a complex technical issue in production environment?
Well, it's quite scary. I work with one developer occasionally whose thing is, since debugging is complicated, just don't write bugs. It's his solution. Why do you write bugs if debugging is hard? And certainly, the advantage of things like Docker and so on, where you have images as opposed to running things in different builds, is that you have a consistent environment. It's easy to replicate some of the issues. So we don't have an issue where this Windows installation is missing a patch or this Unix distribution is missing a certain functionality. So that when you deploy the app in a specific environment, it fails and you don't know why. I think that was always the frightening thing about different Java distributions, was you were never quite sure what it was going to do in some instances. But I think now the issue is, in addition to with having that kind of consistent approach, it makes it a lot easier to figure out and reproduce errors when they happen in production. But the problem is when it doesn't happen locally, what do you do? That's when we've I'm not a big fan of remote debugging because it's always been a bit scary for me. But monitoring tools, good logging and analytics, all of that has really been a help to identifying and figuring out these complicated issues. And a lot of the problems these days, because everything is, all these environments are kind of built as a sort of a discrete unit or, all put together. Instead of using local resources, it's sort of, how can I say, an atomic unit. This is the solution. Now, a lot of the issues are about misconfiguration of resources. We've even had some issues where it's actually a Microsoft Azure issue. They have some outage or some problem, and then it brings a solution down, which is outside of your control. But trying to figure out what's happening and why, that is a bit of a challenge. And we've been leaning a lot on the logs and the analytic tools for that to get it working. The great thing about the compute side of Azure and all those logic apps is you can actually go back and check all of the executions of the different computes and see exactly what happened. And I must say that's been a fantastic pleasure to use when trying to figure out what's gone wrong. You can actually go to that run of the code, step through it, and see where it failed. But sometimes you have to guess. If you speak to mainframe developers, because I've worked with a few, they'll tell you that sometimes because mainframe time was so difficult to get, you couldn't afford to do that. You'd have to print out the code and then, as a mental exercise, step through the code and try and manually follow each path in the code with the parameters you have in order to find the bug. Because there wasn't enough computer time to go around so that you could sit and debug live. So we kind of spoiled these days. You can put a breakpoint in your code, execute it, and then step through the code to see what happens. I mean, that's a real win. But doing the mental exercise of manually figuring out the paths through the code and where the error might be is a great way, is a great tool to have in your arsenal, even if you don't use it very often. And it's a good skill to try and cultivate if you have the opportunity.
Can you describe your experience with Azure-specific services like functions, storage, Cosmos DB, and logic apps?
I must say that storage, it's very difficult. Microsoft is quite clever. Their tools are very convenient, but they're not always very performant. And if you want it to be fast and reliable, you need to pay. And that's been my experience with some of the Microsoft stuff. So it's always a bit of a trade-off, is how much are you willing to pay for performance or convenience versus putting up with the issues and getting it on the cheap. One thing, for example, the Azure storage, by default, it's pretty slow. I'm sure you've noticed the same thing. It's pretty slow. And Cosmos DB is nice and quick, but it's very expensive. So that's these days it's kind of become a big architecture trade-off is how much money am I willing to spend. Also for convenience. For example, if you use Azure functions as opposed to logic apps, or even if you use compiled logic apps, it's a lot easier to build and debug. So your development time might be quicker, but it's more expensive to run potentially. And so the question is, with that trade-off, which is going to be easier? Is it easier to build or run? Also, I mean, the trade-off there as well with the logic apps tooling is if you use their native compute stuff, you get all of the logging for free. You get a bunch of stuff for free, but if you use the compiled one, you have to do a lot of that work yourself, especially for Azure functions. You need to make a lot more decisions. Your developers might need a bit more experience and so on. So some of the trade-offs for architecture seem to be how experienced is the team? How much hassle am I willing to put up with in order to get what I want? And so Microsoft always seems great at making the sweet spot where it's just inconvenient enough to pay for the next level of tooling. Unfortunately, we've been able to keep just under the wire there. So we run things on the cheap, but I'm not sure how long that'll carry on. So it seems to be with Microsoft, it's either cheap or fast, or it's either cheap or convenient, and that's the decision that you need to live with.
How do you approach continuous integration and continuous development, deployment, the CI/CD?
Yeah. Well, look, often if you're using well-known frameworks and so on, there's a lot of good examples provided by the vendors that you can build off, and that's usually a great way to go. If you stick to the middle of the road, the chances of there being major issues with your specific configuration are quite small. But sometimes the biggest roadblock I've had in for working for different customers is actually getting access for the pipeline. So giving the pipeline access to the resources it needs to change or update can be a big challenge. And because of that, we often end up running it off a developer machine, someone who already has the rights needed, because the rigmarole of getting the rights to actually automate some of these processes, it's quite difficult to get through. And also having an account with elevated privileges sitting out there running off your DevOps pipeline can be pretty scary for some of the security people. I understand, because there's no two-factor authentication for your pipeline, right? It's not going to work. So I think that's been the biggest issue, is finding out first, can we actually get a user who can run our pipeline, a user account or a service account that can actually do everything we need to do for us. But the more access you have, the easier it is to automate everything. But it's a trade-off once again. How important is security, and how much do you want to lock it down? I know security is more your thing, but I must admit I do sleep easier knowing that the pipelines we currently have deployed don't have enough access to do any real damage if they were compromised. So uh, that's enough of a trade-off for me to put up with a little bit of inconvenience in manually configuring some things rather than automating them.
That brings me to the next question on how do you ensure security and compliance in the deployment?
It's sometimes tricky, especially with compliance. But security and compliance kind of has to start from the ground up. So even things like logging can expose you to a lot of problems. So there's always this tendency with the developers, you log as much as you can because it makes your life easier when you need to debug. But you could be sort of exposing secrets or giving away the crown jewels there in your logs. And logs aren't generally secured very well, or not as well as they could be. So that's always a bit of an issue, a bit of a trade-off. But so to design with security in mind, to limit what is exposed, what is needed at every layer, that's, for me, that's where it starts. Design for security, write secure code. And then as far as deployments and secrets go, these days it's quite easy. Most cloud frameworks anyway have sort of secure storage, a key vault or something, where you can securely keep dangerous credentials, if I could put it that way, and access them in a safe and secure way. So a lot of our security is built around that, trying to utilize the secure frameworks and tools that are available. It's also true, though, that, new threats come up every time. You can't know everything. One of the things also is third-party, like supply chain attacks. It's very convenient when you're writing something and you need a new feature to simply look for a library that does it and just say, okay, give me this library. But a lot of thought needs to be put into what you pick out of the basket, because you could end up with a poison apple, if you know what I mean? Especially even in the supply chain attacks, when they bury, it's a dependency of a dependency of a dependency that gets pulled in and can open a back door. So that can be a bit of a thing. So if we're going to use third-party stuff, by which I mean not Microsoft or some well-known vendor, be selective about what we pick. And also keep libraries up to date. Even the core libraries, framework libraries for solutions, they discover vulnerabilities all the time. They stop patching stuff after a few years, and you end up code sitting out there that's on a framework that is vulnerable. So being disciplined, and that's where continuous integration and so on comes in. If you have unit tests, you have a pipeline, upgrading a library version isn't a big deal. There's even some great tools out there to sort of automate the process for you, to actually discover new versions of your dependencies and create merge requests for you to review and merge in with the new dependencies inside. So there's a lot of tooling like that out there. Often for our specific use case where we're using it at the moment. A lot of that is too much trouble for us. But for larger projects and bigger solutions, certainly, even now with security and patching and so on, there's a lot of automation available. But you need to trust somebody eventually, and that's always the issue: is the people. Who do you trust?
All right. What excites you the most about the future of cloud development, and where do you see the field heading?
I say for me, different frameworks, cloud, whatever. That's all just a means to an end. I didn't start off being interested in technical problems. I'm more interested in solving business problems, real world problems. But what I like about cloud and AI and so on is it makes the tools for solving those problems more accessible. And I know it freaks some developers out, if it's so easy, am I going to have a job? But really, it's kind of like fourth generation languages instead of COBOL or other things like, drag and drop canvases to design user interfaces instead of having to manually code components and code altogether. It's just an accelerator. And I think with cloud and that, it's getting to the point where people with the domain knowledge can be more hands-on and accelerate the development process for us. But you're always going to need somebody who can talk the computer's language, if you know what I mean. Somebody needs to tell you that what an AI tool has generated is good code or bad code. Somebody needs to be able to explain to the system exactly what is needed and why. And so I think there's always going to be a role for the more technical guys. But I like the way that we're beginning to realize accessibility to this kind of software tooling for business people specifically in a way that makes it easier to get the job done.
What is your philosophy on code organization and naming conventions?
Everyone has their own opinion about this. Generally, if it's an existing solution, I try and find out what the convention is and match it. Or if it's something like a Microsoft's Azure framework, they actually publish naming conventions. There's a document they've provided as to resource naming, how it should be done. Look, we haven't adhered to it in our current solution because the current solution predated the documentation. But I think using the vendor's preferred standards is great. And there's a few things I hate, particularly, like things like Hungarian notation, things like that. But often these standards are entirely arbitrary. And that's the weird thing. There's a great guy called Joe Salka who was involved in developing the ANSI SQL standard. And I always used to love finding stuff in Stack Overflow from this guy. He would crawl the SQL groups and then troll the people who were very opinionated about SQL syntax, for example. And because behind him, behind the development of the ANSI standard, was a whole bunch of scientific analysis, things like read speed for code, scan speed for comprehension, things like that, where they'd actually done scientific studies to determine the best way to write the code and put it so that it would be most understandable and be able to be read as quickly as possible. And I thought that opened my mind as to the level of care you can take, the level of research you can do to find the right way to style or write your code. Not everyone's going to be able to put in that amount of money, time, and effort to figure that out. But using established standards like that, the guy's got research behind why he does something. Why not do it that way? If it's a proven value add. But not to get too hung up on my own personal likes and dislikes, tabs or spaces, things like that. But rather to find out why are we doing it this way? Ask that question. Why are we doing it? What value do we get out of doing it that way? And then try and be consistent through a code base. If you find something that you don't particularly like, which has happened to me in a code base, match the standard rather than try and establish a new one. Then at least it's ugly, but it's consistently ugly. And it allows you to understand it a lot easier. The more similar the code is, the easier it is to see things that are different, like bugs. And so when you're consistent with the standard at least, then you're doing yourself a favor and the next guy too.
What advice would you give to someone who wants to break into the cloud development career?
It's quite a broad thing these days in the cloud. There's people who actually keep the stuff running, and there's people who do the design and the architecture, and there's people who actually implement the functionality. One thing that I found advantageous for myself is to understand software design principles. Like if you know what a service bus is and what problem it solves, then the tool in the cloud makes sense, in a cloud framework. If you know how compute helps you, that's great. So just to know why we have the tools can be a big advantage. And the architectural principles behind the tooling they provide also translate to other more traditional kinds of software development as well. So understanding design principles for me is a great starting point to know what's available. It will help you understand how to use what cloud vendors make of it.
What is the best advice and worst advice you've ever received?
About software development or in general?
Just in general.
Yeah. It's quite a broad question. I'll have to think about that a bit. Some good advice, for me at least, work-wise, for software development, has been to always assume that everybody knows more than you do. And it's a great way. It's actually a lot easier to work with people who are like that as well, who are willing to learn and listen. Also, the best ideas don't always come from the senior people. And as you become a senior person, you realize you don't always have the best ideas either. So definitely trying to cultivate that sort of attitude has helped me a lot. That was good advice. Yeah, I don't know. I've always got benefit from advice, good or bad. I think I'll have to think about that as well. Get advice all the time. I think some of the some bad advice I got was to chase after the money. So career-wise, some people will tell you that they find a better job, or that they find a job that pays more, especially consultants, and they'll drop their current job and run after it. But that's not always good advice. It's not always good for you. And you learn quickly there's a lot more to job satisfaction than what you earn. I know people who've done that who end up being very unhappy in a new role when they were quite satisfied with the one they had.
Thank you for sharing your insights, and it's been a pleasure having you today.
Thanks. Thanks for making the time. And it's always interesting to revisit the past, even if it's chatting to you. It's been quite an interesting trip down amnesia lane. So thanks for that.